Hey guys, this video here we're going to be learning how to change spark plugs and servicing spark plugs. Spark plugs, every gasoline powered car has spark plugs. Depending on how many cylinders that car has, that engine has, then I'll determine how many spark plugs. So here I have a simple display that I put together a few years ago and it demonstrates spark plugs in relation to each other, and I got it powered up by a 12-volt battery. And if I rotate the distributor, you can see here how they're sparking. I don't know if the camera can pick that up. And you notice that they're all sparking at different times. We're going to be discussing that shortly in the next part of the video. We're going to be discussing what we call a firing order. Okay, so there's a couple things in this video we're going to discuss. We're going to discuss what type of spark plugs might be in your engine. We're going to be discussing how to replace spark plugs, or how to identify how the engine is burning based on if the engine is running too cold or running too hot, or if the engine's burning a little bit of oil and maybe burning a little bit of coolant. We can tell that by pulling the spark plugs out. Your teacher might have you replace spark plugs, so this video is about replacing spark plugs, or your teacher might have you put in the old spark plug back into the engine so the next student can have a turn at doing that. Okay, so in this section here, we're going to discuss when you're starting your assignment, when you're starting your spark plug project, there's two things that you're going to be asked to do. Number one, you're going to determine what the spark plug torque should be, so the suggested amount of tightening for the spark plugs, and you're going to be asked to write that down somewhere, or maybe just show your teacher on the computer that you pulled it up. So we currently have a subscription to an online how-to online service manual, and we're using the Mitchell. I think the subscription we have right now is through the Pro Demand. They used to be called the Mitchell On Demand, but nevertheless you need a service manual to find out the suggested torque. Also, you can either print, I've asked my students in the past to print, or you can maybe call your teacher over to show you, to show them that you've pulled it up on the computer. You want to find out the firing order, and there's a couple of reasons why you want to do that. Number one, if you're working on an older engine that has a distributor, I'll show you that in a couple of minutes. These distributor style engines have spark plug wires, and they have to go in a specific relationship. Now, the firing order of this engine that we're going to be looking at, one of the multiple engines, is 1342. This is a very common firing order for a four-cylinder 1342, and it shows you where the front of the engine is and in which cylinder lines up with which cap or which position on the distributor cap. So if you take a look at these different engines we have over here. Okay, so on this engine here, which is the exact engine of the printout that I had just a second ago, this engine has spark plug wires, and so this is important. So if I pull this spark plug wire out from this cylinder here, so it lines up specifically with this spot on the distributor cap. Now, they're interchangeable. It's not like this is a square peg and this one's a triangular peg and this one's a round peg. They're all the same shape, so you can mix them up and then the engine wouldn't operate correctly. If we go back to the beginning of the video and I showed you how the spark plugs were firing at different times, this is what we call a firing order. So in this case, this firing order for this engine is 1342. So we have cylinder number 1 firing, then cylinder number 3, then cylinder number 4, then cylinder number 2, in that exact order. And if I mix up the wiring, then what ends up happening is the engine doesn't run right, or might not run at all. Okay, you can see on this engine here, there are no spark plug wires. This engine here has one ignition coil per cylinder, whereas an engine with a distributor, like the last engine, it has one ignition coil, and the distributor distributes the high voltage energy from that ignition coil amongst all 4 cylinders, or 8 cylinders, or 6 cylinders, whatever amount of cylinders we have. So modern vehicles don't have distributors. If you like classic vehicles, you're going to be working on distributors, but modern vehicles do not. This one has no spark plug wires going to the spark plugs. We're going to be learning how to changing spark plugs on this engine. So on this engine here, we have a snowblower, and this is a single cylinder engine. And on this engine, if you want to zoom in, you can see how this engine only has one cylinder, and I can identify that because it only has one spark plug and one spark plug wire. So I would simply just remove the spark plug wire, and I can access the spark plug itself, remove it, maybe clean it, maybe regap it, maybe put in a new one, whatever the service requires. I can do that right from the spark plug right here, the one cylinder. Okay. Now you can see on the top half of this shop car here, this car belongs to our shop, we have our spark plug wires on the top half of the engine. Now this engine does not have a distributor, but yet it still has spark plug wires. So what they're doing on this engine, instead of an ignition coil directly on top of the spark plug, they're putting the ignition coils off to the side, and it looks like they're sharing ignition coils. So we only have 2 ignition coils shared amongst 4 cylinders. And when that ignition coil ignites, it'll ignite 2 cylinders at the same time. One of them will be on the power stroke, and the other one will be on the exhaust stroke, and that'll fire the spark plug at that exact time. Try to really burn and clean up the exhaust pollutants. Okay, so that's, again, no spark plug, no ignition coils on the on top of the wires. So in this case here, we would have to identify these. So before I pull this out, I'd want to put a piece of tape on here, identify what cylinder that is, and so on and so forth, so I don't mix them up like I explained before in the past. Okay, so on this shop car over here, this one's a little bit unique compared to the others. This is a V engine, this one's a V6, and you can see there's only 3 spark plug wires in the front half of this car. This is the side of the engine. And the other 3 would be on the back side. So it's not visible right now until we would get into the back half there. It's a little bit difficult to show on camera, but nevertheless they're there. So again, I would put a piece of tape. So this one has a piece of tape, and I would write on here what cylinder this is. Okay, so before we pull these spark plugs out, we'd have to identify them so we can put them back in the same spot. So here, I put a piece of tape on here. I would label that depending on what cylinder number that is. How would I know what cylinder that was? That's by pulling up the firing order on the service manual and indicating this is cylinder number 2, 4, 6 potentially, or 1, 3, 5 potentially, or 4, 5, 6 depending on the cylinder, depending on the manufacturer, or 1, 2, 3. So every manufacturer labels their cylinders differently, but nevertheless you would have to label it according to the service manual so that you can put them back in the exact spot as they were before. Okay, so on this shop car here, you can't see the spark plug ignition coils or the spark plugs or the wires because it has one of these covers on here. The reason why manufacturers put these covers on here, for one thing, you open the hood, it looks pretty. It identifies the manufacturer, maybe some information regarding the size of the engine or the configuration of the engine. It also acts as a sound barrier to quiet the engine down for the passengers inside. So nevertheless, we have to remove this cover to access the spark plugs or the spark plug or the ignition coils. So I'm going to go ahead and do that. And this one, it just simply pops up. Now, you can see here, it's a 4-cylinder engine. We can see we have 4 ignition coils directly on top of the spark plugs. So I would have to remove these, what we call the primary circuit. So I'd unplug this plug here. I would remove the 1 bolt holding the ignition coil in. And one thing you might notice in the video is that this is extremely dirty. Now, one thing that you're going to have to do is you're going to have to get an air blower and blow off any sort of loose dirt or loose particles, because once we remove the spark plugs, that's an access point or a window into the engine. We don't want any of this dirt entering into the cylinder. It just takes 1 grain of sand to gouge a nice deep scratch into the cylinder wall between the cylinder and the piston and the rings. So we got to remove all this dirt, and this tends to happen in Canada here. Underneath these covers, we get a little bit of mice sometimes moving in, and in this case made a little bit of a mess, or there's a lot of dirt here just from road debris. Okay, so on this section of the video I want to discuss the cylinder head. The reason why I'm discussing the cylinder head is because the spark plugs will be bolted to the cylinder head. Now, the material of the cylinder head is really important, because that will determine a couple of things. Some preparation of the spark plugs before you install them, or how do we, what kind of a level of aggression do we use? Always a little bit less, but nevertheless, maybe you need a little bit more of aggression. So here I have a magnet, and a magnet, guys, only sticks to ferrous metals, like iron, and I'm going to use this magnet to determine if I have an iron cylinder head or an aluminum cylinder head, because these are the 2 popular materials. So this is from a classic vehicle from the 70s, and you can see here that the magnet sticks to it. I don't know if you can tell that, but it does want to stick to the cylinder head. So that's an iron cylinder head. That's very rigid, very heavy, so it can handle a little bit more abuse. Most manufacturers are not using this anymore because it doesn't dissipate heat very well, and it's extremely heavy. So here we have an aluminum cylinder head, and how I can tell that is the magnet does not stick to it. Okay. Also, aluminum doesn't rust. It does oxidize, But when iron rusts, it turns to this brownish material, brownish color, where aluminum usually keeps this silvery material, silver color, or it could turn white over time. So this is an aluminum cylinder head, which is what we're going to be doing on our practice engine. Now our cylinder head, once I have it up on its side, since this one is disassembled, I can show you with my screwdriver. Where does the spark plug sit? It sits right here in the combustion chamber. We have the intake valve and the exhaust valve, and the spark plug would be poking its little nose right out the tip here, and that's where it produces its spark, and that's where it would ignite the air and fuel in this area here. Okay guys, on this engine here, we're going to be removing the spark plugs. I'm going to be removing the air cleaner. You can see, we can only see 2 ignition coils, and I've already unbolted the air cleaner. It just pops off. Put it off to the side. Okay, so before I remove any of the ignition coils, there's a lot of road dirt on top of the engine. I'm going to take my air blower and connect it to the air hose. I'm going to put on my safety glasses, and I'm going to give this a quick clean up. Now this one's been taken apart quite a few times, so it's not too dirty like that other apartment we saw. I'm going to be removing cylinder number 1 ignition coil. How do I know this is cylinder number 1? Well, if we look down over here, we see the serpentine, or we see a serpentine belt, or also known as a drive belt. Anytime you see the belts, they're always on one side of the engine. This is the front of the engine. This is it. Front of the engines are identified by the belt. Now, there are timing belts and timing chains. They're not visible. They're usually covered, always covered. And some of them are on the back of the engine, but the serpentine belt and the, like for the alternator, in this case, the air conditioning compressor, water pump, whatnot, they're going to be on the front. Okay, so I'm going to do cylinder 1, and I'm only going to do cylinder 1 for this video. So I'm going to do, remove my ignition coil first. So this one has a 10mm bolt holding it in place. And you can see the 10mm bolt once it stays stuck to the ignition coil. Now, when I go to pull this ignition coil, I'm not just going to yank it. I want to twist at the same time as lifting. Okay? Now there it is. There's my ignition coil, and there is the wire, or in this case, the boot. We call it the boot, leading towards the spark plug. We're going to look at this boot, and we're going to look this for any sort of tears. So there might be a discoloration there. I don't know if that's from my oily hands. But if this boot is in bad shape, then the spark will not get to the spark plug. It'll leak out the side, hitting the aluminum cylinder head. Okay, so that one looks like it's in pretty good shape. This engine did run, it ran well. So now, before I pull the spark plug's in the hole, I'm going to air blow that hole. I'm going to grab the air blower again. Give it a little shot. Any sort of debris in there has got to come out. Okay, I just finished air blowing the hole in the cylinder head regarding the spark plug. And one thing you do before you put the tool in there, you got to take a look in the hole, and you might need a flashlight. It's hard to see. But is there any oil in it? Is there any debris? So I just finished air blowing it, and I don't see any oil in there, so that's good. I can go ahead and remove that spark plug. These type of cylinder heads, where the spark plug is in the center, they have a tendency to have a little gasket there, and the gasket can go bad, and oil can enter into where the spark plug is, which we don't want that. Okay, so what we're going to discuss, before we pull that spark plug out, we're going to discuss the tools needed, okay? So you need a spark plug socket. There's 2 different sizes that we have in the shop. Cars do come in different sizes, but the most common are 5/8 or 16mm, or 13/16, which would be something on an older vehicle, maybe even a lawnmower or snowblower. We can use this one. And then we have sockets that have a built-in flexible component to it. Okay, universal joint built in, and they come in different sizes. Now, some modern vehicles, like some BMWs and Toyotas, they have a smaller version of the spark plug socket, and it might even be 12 point. In this case, this is 6 point, which is what we're going to be using for this engine here. Now, another thing I want to discuss, I'm going to pull out the spark plug here. So here's the spark plug, and this one is the larger one. If we can take a look, I don't know if the camera can pick this up. If we can take a look inside the spark plug socket, you can see there's a rubber grommet in there. Okay, you can see there's rubber grommets in there. Let me see if I can pick this up. Those rubber grommets, the purpose of that rubber grommet, if you stick the spark plug in there, it should hold the spark plug in its place. Also, when you're tightening or loosening, the torque from the movement of the ratchet could lean the socket left or right, and what ends up happening is we're going to be asking the spark plug to bend. Steel can bend, it can flex, but the center portion here, if you notice, all the spark plugs are kind of the same. They have this white portion there, that's ceramic. That ceramic is designed to insulate the current as it flows down the center of the spark plug to the tip, so that it doesn't leak out to the side where it would ground on the cylinder head, okay? So we use ceramic, not rubber, not plastic, not wood, because it needs to handle heat. There's a tremendous amount of heat in the cylinder, and this spark plug needs to handle the heat. Ceramic does not react to heat the same way that metal does, or obviously as plastic or wood would be. So we need something to insulate, but also be strong and handle heat, which the ceramic does. Okay, so now I've identified with this engine here, I need to use the smaller diameter socket. So that's going to be these two, one of these two. Now, if I look at the outside dimensions of the socket and versus this one's a little bit larger. This is the preferred socket, is the one with the flexible joint built into the socket. This is the preferred socket. Now, this socket here, this extra girth, does not fit in the position where the spark plug hole is. So we can't use this one, so I'm gonna have to go with the thinner socket. Now, this one does not have a flex built into the socket, so then I have to choose my extensions or my ratchet very carefully. Now, if we take a look at these two different extensions here, we have they're both 3/8 drive. Here is a traditional 3/8 drive extension, and you can see the tip is somewhat square versus this one here. This is a 3/8 extension. This is what we call a wobble extension. So I'm going to show you what the difference is. So if I put this 3/8 extension on the socket, there is very little to no flex. Okay. If I put the 3/8 socket on the wobble extension, you can see there's allowable movement, and that's similar to the preferred socket, which in this case is a flex socket, but it's not going to fit. Okay, so we're going to have to use this spark plug socket, which has a rubber grommet, with a wobble extension. Now, choosing the correct ratchet. You can use this ratchet, that is fine. You can use that. Now, the thing is though, you're going to want, again, a little bit of flexibility. And that's where this ratchet comes in place. It's got a flex head. Sometimes you might, when you're buying ratchets, this ratchet might be identified as a spark plug ratchet, and that's fine. That's what we're going to be using. So this is our options here. We're going to be using, on this engine, a flex head ratchet with a wobble extension and a chrome socket. Ideally, you would want to use this type of socket if you have. Again, it's a spark plug socket, and I identify that because it has the rubber grommet inside. And I'm going to be using the traditional 3/8 extension, and I would probably still want to use the flex ratchet there, ideally. It's a great ratchet. Okay, now you can see here, just to demonstrate that again, here's the flex socket, and you can see it does not fit inside the hole where the spark plug is. I can't fit it in there at all, so I'll put that off to the side. And here is my skinnier spark plug socket, and it slides right in. And I'm going to make sure that it's properly seated onto the spark plug socket. You see I have to turn it a little bit and naturally sat into it. And I can't rotate it by hand. That's seated properly. It's pushed all the way down in. Okay. Now I'm going to grab my ratchet, and I'm going to make sure it's in the off position. And I'm going to loosen and remove the spark plug for cylinder number 1. It's very loose, so I can remove the ratchet now. I can just do it with my hand. This one's been out a few times. I've used this this engine this past semester for the first time. We just took this out of a car that was donated. The car was in an accident, and we took the engine, which was running. Great little engine, and great little demonstration. Okay, so here we are. Now, I'm going to pull this loose. It doesn't want to loosen anymore. I'm going to pull the extension out and the socket. Ideally, the spark plug will sit in the socket if the rubber grommet is there and if the rubber grommet is in good shape. Now, it's possible that the rubber grommet is not in good shape and it wouldn't sit. Let's pull it out and see what happens. And you can see here it did not come out. So what are my options? One, I can get another socket with a brand new rubber grommet in there. I can purchase these rubber grommets. Okay, so obviously the spark plug did not stay in the socket. There is a grommet, but the grommet is worn out. It's been used quite a bit. This is an old Canadian Tire spark plug socket. This is not some fancy, just a Mastercraft. So nothing too fancy here. Anyways, I can grab a magnet here, and that magnet will also grab the spark plug. I gotta be careful, I don't want to drop that spark plug. There it is, okay? Okay, so we have the spark plug we just pulled out, and two things your teacher's gonna ask you to do. So if you're practicing how to change spark plugs on an engine, the objective is to put the spark plug back in the engine so that the next group of students can practice on the same engine. If you're replacing spark plugs on a vehicle that's gonna be driven, then you're gonna be grabbing a new spark plug that should be the identical spark plug. So you're going to have to purchase new ones. It's not one stop. They're not all the same. As you can see, this one's a little bit different. They all come in different shapes and sizes and heat ranges and thread pitch and reach. They're all very, very different. Materials are made from. You got to make sure you buy the right one for your car. Okay, let's discuss practicing like I would first-time students learning how to do a spark plug. So what I'm going to ask you guys to do is two things I'm going to ask students to do. One, you're going to look at the tip of the spark plug and you're going to examine the tip and you're going to compare it against a chart indicating what is the condition of the spark plug. Is it running too cold? Is it running too hot? Are we burning oil? Are we burning too much fuel? Are we burning coolant? So on and so forth. And you can tell that by the color on the tip. Okay, so this is the U spark plug. You're going to examine that. You're going to discuss that. You're probably going to write it down on your project, and you're going to hand that in. And you're going to discuss that for each individual cylinder. So cylinder 1 is like this, cylinder 2 is like that, and so on and so forth. Okay. Next thing we're going to ask you to do. One of the things I asked students to do at the beginning of the project is find out the torque and the firing order. Something else you have to do is find out what the suggested gap should be. Now, the gap is this space you can see here on the spark plug. That space is where the spark happens. If the space or the gap is large, then you get a long spark, also a weak spark. If I want a strong spark, I have to close the gap up. But if the gap is too small or too short, then it won't burn all the fuel in the cylinder. So it's a mix between performance, fuel economy, tailpipe emissions. You have to get the suggested amount of gap from the service manual, and then what you're going to be asked to do is find out what the gap is. Remember, we're just talking about practicing. Find out what the gap is of the old spark plugs. If you're installing new ones, I'll show you how to do that. Okay, so let's take this. There's two different types of spark plug gappers. Okay, this one has these different types of wires all the way around indicating the thicknesses of them, and there's the metric side and there's the imperial side. Now let's find out what fits here. So I got this size here, doesn't fit. Next size, I'm just putting a little bit of pressure. I'm not forcing it in. That one fits, but zero effort to put in. Okay, let's go a little bit. That was it, yeah. So those are the only three options. So I got 0.4 inches, 0.04 inches, doesn't fit. 0.035 inches fits with no resistance whatsoever. So I'm somewhere in between 0.035 and 0.40. To find out the exact size, I would use this stepped gap gauge, and I would just slide it across, and I can see here that I'm at, looks like 0.38. I don't know if you can see that on the camera, if you can see those specifics. Now, I'm not forcing it around, I'm not wedging it in there. I just, wherever it stops, I'm using very little effort, pressure to push it in there, and I can see it lines up with 0.038 of an inch, okay? And you also have the metric side on the other side, okay? Now, if you had to gap your spark plug, so let me get this new spark plug here. If I had to gap the spark plugs, I would use this spark plug gap gauge, and these come in different types of handles and whatnot, but what we're looking for is this tip here, okay, or that tip. And what I want to do is, whatever the suggested gap is, we're going to say this gap should be, let's say, 0.035. Okay, so again, if we're putting in new spark plugs, we have to gap them to the suggested amounts. If you're practicing, all you're asked to do is find out what the gap is if it's at the suggested gap. Okay, and you just write that down because the next group of students want to test that. So in this one here, we're going to use 0.035 inch, and it doesn't fit. So what I'm going to do is I'm going to take this tip here on the gap gauge, To open up the gap, so I want to try to gap this spark plug to 0.035, and you can see it doesn't fit here. So what I need to do is I need to open up that gap. So what I do is I take this tip of the spark plug gap gauge and I lean it open to try to open up the gap a little bit, right? And I used very, very little effort, and you can see it fit in there. Now it fits actually overly, it's too much. So now I got to go back the opposite way, put that on there, and just lean it back down. Very, very little effort is required. Okay, I'm going to try that again. And where would I get these specs? That would be on the service manual. And I should feel some drag as it goes in. And if I don't feel drag, then it's not right. Nope. There we go. A little bit of a drag, a little bit of pop there. And that gap there is 0.035 inches. If that's the suggested amount, then I'm going to go ahead and install that. Okay, installing spark plugs. Couple things. Now, we talked about metal before, cylinder heads being made out of iron versus cylinder heads being made out of aluminum. If you go back to science class, I think we talked about it in grade 9 science, we talked about dissimilar metals reacting to each other. So this spark plug section here is made of steel. Now, what kind of steel? There's many, many different types. Nevertheless, no spark plug, no cylinder heads are made of steel. They're either made of iron or aluminum. And in a lot of cases, these spark plugs will sit in that cylinder head for 100,000 kilometers, 150,000 kilometers. Sometimes the car doesn't make it that far, or you're only putting one set of spark plugs in the whole life of the car, and then the car gets thrown out. Now, the question is, this is a different metal versus the aluminum, so we have to consider that this may seize in the cylinder head. Now, these are both new spark plugs. You can see here that this one is just got a zinc coating. This also has a zinc coating. This one's a golden zinc. This one's a silver zinc. Will this gall up and seize in the cylinder head? Possibly. So read the packaging of the spark plugs where you got them from. It may say, do not put anti-seize. If it doesn't say that, then you'd want to apply a little bit of anti-seize on your spark plugs, and the purpose for that is simply to reduce the chance of that spark plug seizing in the cylinder head. Now, how much do you need? Very little, because anti-seize doesn't mix well with the catalytic converter further down into the engine. Now, it doesn't do any damage to the aluminum cylinder head or the aluminum piston or the cast iron sleeve or the engine oil. It doesn't do bad in that. It does poorly when mixed with the catalytic converter or the O2 sensor, but very, very little. You notice I only put a little bit of anti-seize on one side of the threads, and as I put it in and I turn it, what happens is it wipes itself around, and I didn't put it on the first couple of threads, and that's going to prevent me from getting into the combustion chamber. Again, you got to check the packaging of the spark plugs you get. Now this one, I read the packaging of these V-Power NGKs. This one specifically stated don't put anything on the spark. I wanted it to be dry. This one didn't say anything at all, so I would apply a little bit of anti-seize on this type of spark plug. Another thing I want to talk about here, guys, is the type of spark plug you're putting in. You don't have an option as a consumer. I'm not engineering the vehicle, so what happens is I have to make sure that the spark plug is designed for that car. You can see on this new spark plug, it has this loose like washer on here. This is a type of a gasket, a type of a seal. It's a type of a crush washer. It's a one-time use. This spark plug here does not have one built in, so this one here is a conical shape, usually around 60 degrees, and this will have an interference fit against the cylinder head. So we have to understand the type of spark plugs that your engine requires and make sure that you're purchasing this right one. This one has a gasket, this one does not. The ones on our example does have a gasket, and you can see it's slightly crushed. So that's been taken out and put back in. This is my practice engine, and I just want to identify that in the video. Okay, so now we're going to put our spark plug back in. So this is our practice engine. So what did I do for my teacher is I pulled the spark plug out. I identified how that cylinder is burning comparing to the chart, and I checked the gap. I wrote that down. Now I got to put the spark plug in, and I got to torque it. I got to tighten it to a specific tightness. Now, if we remember back to this spark plug socket, it wasn't holding my spark plug when I pulled it up, right? It came out too easily. So what I did is I went and I grabbed another spark plug socket, and this is a newer one. So let's check to see if it'll hold my spark plug, and it does. That's what I want, okay? I want to be able to thread the spark plug in by hand. So let me get rid of this old spark plug socket. And I have the spark plug in the socket on the extension, and you can see my extension has a little bit of a knurled section, some grip. I'm going to use that to thread. I want to thread this in as far as I can by hand until it's tightened up, and then I'm going to use a torque wrench. Okay, I don't just grab a ratchet and start turning because it could be cross-threaded. I don't want to do that. So I'm just going to thread this in all the way in. Now your teacher might want to see that these spark plugs are going in by hand before you put a tool on it, before I put a ratchet or a torque wrench, okay? Actually, I'm not going to use a ratchet at all in this step. I'm going to go straight to the torque wrench. There it stopped. I'm going to call my teacher over. He or she is going to double check that there's no cross threading on the spark plug and the threads inside the cylinder head. If there are, you're going to damage the cylinder head, and it's a serious engine repair. Okay, so that's as tight as I can by hand. I'm going to grab my click type torque wrench in this case. Depending on what kind of torque wrench you have in your shop, it doesn't really matter, but nevertheless, I want to torque that to the suggested amount, and I want to show that torque wrench that's set to my teacher before I get started. I'll put my torque wrench on there. I'm going to support the head. I'm going to keep on turning until the ratchet clicks. There it is, it clicked. And then I'm going to call my teacher over again to see that the torque wrench clicked at the desired amount. So I'm going to show my teacher that the spark plug went in by hand smoothly. Then I'm going to show my teacher the torque wrench set to the desired torque. Then I'm going to show the teacher that the torque wrench has been, or the spark plug has been torqued. And then what I want to do is I want to take this torque wrench, and I want to lower it or zero it to its lowest number. In this case, this type of torque wrench, I'm going to have to do that. Some torque wrenches you don't. This is a micrometer type quick type torque wrench. I'm going to lower it to its lowest amount, and I'm going to put this away. Show that to my teacher first. Okay, so I'm going to put my torque wrench away. I'm going to take my spark plug socket and my extension out. Sometimes these spark plug sockets get stuck in there. You might have to grab a magnet or a long skinny set of pliers. Then I'm going to grab my ignition coil and the boot. Now this ignition coil, you don't have to, but this ignition coil could have been numbered. So that's cylinder number 1 ignition coil, cylinder number 2, so on and so forth. I'm pretty sure they're all the same, but there might be a situation, it might be shaped differently just because of the engine design. So I'm going to put that in by hand, make sure that firmly goes in, and I'm going to take this bolt and I'm going to thread that in by hand. If I have a hard time where my fingers don't fit in here, that's fine. I can grab my tools, remove any sort of leverage, in this case the ratchet, and I'm just going to use the socket or the socket and extension, and I can thread it in this way, just like I did the spark plug. I'm going to thread it in all the way in. Okay, you might want to show your teacher that. There is a desired torque for that. Your teacher might ask you to set it to desired torque, but since this is our practice engine, I'm just going to use very little effort, very little pressure. You can see here I'm not fully grabbing the ratchet, just some light pressure, because the next group of students are going to come and remove that. Okay, so these spark plugs are done, and I'm going to be putting the engine back together in the sense that I put the air cleaner back on, that I have removed at the beginning of the video, and maybe your engine has a cover, maybe it doesn't, but your teachers are going to ask for you to put it back so that it's ready for the next group of students. Nevertheless, we're done. This is the spark plug project. We've removed spark plugs. I've checked their gap. I've checked the condition, how the engine's burning. I've torqued the spark plug back up, and I had my teacher check at various steps. Congratulations.